Hello, this video is for textbook chapter 1 lesson 6. It's titled Order of Operations, where our objective is to use the order of operations to simplify expressions. The vocabulary for this lesson is order of operations. So who uses this? Well, sports statisticians use the order of operations to calculate data. We'll see that in example 5. So a baseball player must first run A baseball player must run to first, second, and third bases before running back to home plate. In math, some tasks must be done in a certain order. When a numerical or algebraic expression contains more than one operation symbol, the order of operations tells you which operation to perform first. Here we have a table with the order of operations. First, we have to perform operations inside grouping symbols. Next, second, we have to simplify powers and roots. Third, we perform multiplication and division, going from the left to the right. And then finally, fourth, we perform addition and subtraction, going also from the left to the right. Grouping symbols include parentheses, which we see an example of parentheses here, brackets here, and braces, these squiggly looking bracket things. If an expression contains more than one set of grouping symbols, simplify the expression inside the innermost set first. Follow the order of operations within that set of grouping symbols, and then work outward. In example 1, simplifying numerical expressions, it says to simplify each expression. And over here to the left, we have a helpful hint. You're probably familiar with this. Please excuse my dear Aunt Sally. The first letters of these words can help you remember the order of operations. P is for parentheses. E from excuse is for exponents. M and D is for multiply and divide, going from left to right. And finally, A and S is add and subtract, going from left to right. So let's simplify each of these expressions. Here we have negative 4 squared plus 24 divided by 3 times 2. So let's rewrite the expression. We have no grouping symbols, so it's the same thing on this line. Next, we need to simplify the powers, E for exponents. So we have negative 4 squared. Now, be careful here whenever you do this. If there were parentheses here, then that would be negative 4 times negative 4. But since we don't have parentheses, the exponent only applies to the 4 itself. So 4 times 4 is 16. So we simplify that to negative 16. Next, we need to go ahead and do the multiplication and the division that's in the problem. So we see here that we have 24 divided by 3. 24 divided by 3 is 8. We bring down the negative 16 and the times 2. Next, we need to do this multiplication here before we can do the addition. 8 times 2 is 16. Bring down the negative 16. And finally, we can do the addition here. Negative 16 plus 16 happens to be 0. So this expression here simplified down to 0. On example B, we do notice that we have some brackets here, and we also have some parentheses as well. So there are two sets of grouping symbols. So let's go ahead and rewrite the expression. Now let's work from the inside out. Before we can do the brackets here, we have to do the parentheses that we have here. And 5 minus 2 is indeed 3. Bring down everything else, the 4 that's outside the brackets, the 25 minus, and then also the exponent. Next, we need to go ahead and deal with what's inside of the braces here. Treat them as their own special little problem here that we had to continue working from the inside out. So let's take 3 and square it. That's 9. Bring down everything else. Now we can do what's inside the bracket here of 25 minus 9 is 16. We bring down this 4. Notice that there is no multiplication sign between the 4 and the braces. So the absence of an operation symbol lets us know that it should be, and we should use, multiplication. So this means 4 times whatever's inside the bracket. We simplified the bracket to 16, so that means 4 times 16. 4 times 16 is indeed 64. Let's go ahead and do the simplify each expression here and the check it out. So we have 8 divided by 1/2 times 3. Well, we only have multiplication and division here, so we're going to work left to right. 8 divided by 1/2. Well, I could write that as 8 over 1 divided by 1/2. We know that whenever we divide fractions, we can keep the first, 8 over 1, flip the second, 2 over 1, change the sign to multiplication. We would have 8 times 2 is 16 over 1, and anything over 1 is equal to itself. So this first part here, 8 divided by 2, simplifies to 16. Now I was going to divide. Actually, I need to multiply. So 16 times 3 is going to be, what is that, 48? Equals 48. Let's do this one down here on the end. So we have brackets and we have parentheses. So let's go ahead and bring down our negative 20. We can't do anything with that yet. We have the divided by. We have the braces. Then we have negative 2 times the quantity of 4 plus 1. So let's go ahead and do the 4 plus 1. 4 plus 1 is 5. And bring those braces down. So now I need to do what's inside the braces. Negative 2 times 5 is negative 10. And I have negative 20. Bring down my divided sign. Now, negative divided by negative is a positive. 20 divided by 10 is 2. So 1c simplifies down to the answer of 2. Moving along to our next page here, we have example 2. Evaluating algebraic expressions. Evaluate each expression for the given value of x. Now remember that whenever we evaluate an algebraic expression, they're going to give us a value for the variable. In this case, it's an x, and they're telling us x equals 7. In order to evaluate an algebraic expression, we must substitute the value that they give us for that variable. So we're going to substitute in 7. So rewrite the problem, 20 minus x plus 2 times 5. For the x, we'll substitute in 7. Now we have 20 minus 7 plus 2 times 5. Well, we have subtraction, addition, and multiplication. Before we can do the subtraction and addition, we first have to do the multiplication here. So let's multiply 2 times 5, and we get 10. Now we have 21 minus 7 plus 10. Now let's do the addition and subtraction, going from left to right. 21 minus 7 is 14. Let's bring down the 10. Now 14 plus 10 is 24. So for example A, whenever we simplify this algebraic expression, it simplifies down to a value of 24. On example B, we have 5 squared times the quantity of 30 minus x. And for x, we have to substitute the value of 24. So let's rewrite the problem. 5 squared times the quantity of 30 minus x. We're going to substitute 24 for the value of x. Now before we can do the exponent here with 5 squared, we have to deal with the parentheses. Please excuse my dear Aunt Sally. P comes first. P is for parentheses, so we have to do the parentheses. 30 minus 24 is 6. Now we can do exponents. Please excuse. E is for exponents. We've taken care of all the parentheses. Yes, we have a parentheses here around the 6, but this is just holding the 6 in place and letting us know that this is multiplication that exists between the 5 squared and the value of 6. So 5 squared is 25. Now we can do the 25 times 6. 25 times 6 is 150. Let's evaluate each expression for the given value of x. So let's just do 2b on this one. So let's go ahead and start rewriting the problem, but wherever we see an x, we're going to put in 6. So I have an x here. 6 times 2, and the 2 is squared. So let's go ahead and get rid of that parentheses so I fit that square in there. Divided by the quantity of 2 plus 6. So let's go ahead and deal with each of the parentheses first. Well, first I have to deal with this 2 squared right here. And 2 squared is going to be 4. So I have 6 times 4. Keep that divided there. And while we're at it, let's deal with this parenthesis here. 2 plus 6. Well, 2 plus 6 is going to be 8. Now, I need to go ahead and, actually what I need to do is I need to slide this over here a little bit so I can continue working. So let's move that over here to where I have some more room to work. Now, I need to deal with the parentheses here. 6 times 4 is 24. Now let's bring down the divided by 8. Now we can go ahead and do the division. 24 divided by 8 is 3. So for 2b, the answer is 3. Next, we're going to talk about fraction bars, radical symbols, and absolute values. Fraction bars, radical symbols, and absolute value symbols can also be used as grouping symbols. Remember that a fraction bar indicates division. And I'm glad they say this because I'm always saying fractions are actually just division problems. Every fraction is just the representation of a division problem where the numerator, the number at the top, is getting divided by the denominator, the number at the bottom. So simplify expressions with other grouping symbols. It says here simplify each expression. And I'm looking over at the helpful hint. And yes, actually, I might pull up a calculator and do that, what they're saying here. So let's go ahead and look at this. You may need to add grouping symbols to simplify expressions when using a scientific or graphing calculator. To simplify 2 plus 3 over 4 minus 5 with a calculator, you would enter the quantity of 2 plus 3, notice how they're using parentheses, divided by the quantity of 5 minus 4. The reason for that is you're letting the calculator know that first you have to add the 2 and 3, then you have to subtract the 4 from 5. Then once you've done that, then you can do the division. So notice that the fraction originally does not have grouping symbols, but yet the fact that this is a fraction and the numerator has to be simplified as much as possible, then the denominator simplified as much as possible, then you can do the division that exists between the numerator and the denominator. So even though we don't have the parentheses at the numerator or the denominator, we understand that the numerator has to be simplified, the denominator has to be simplified, and then we can go ahead and do the division that the fraction bar implies. So let's go ahead and work this one out here. Simplify each expression. Negative 22 minus 2 squared over 5 minus 3. So let's go ahead and put the grouping symbols around the numerator and the denominator. Now let's go ahead and take care of this exponent of 2 squared, and that's 4. Everything else we brought down from the previous line. Now we can go ahead and simplify the numerator. 22 minus 4 is a negative 26. 5 minus 3, oh, they just brought that down. They just simplified the numerator. Now they simplify the denominator. 5 minus 3 is 2. Now we can do the division of negative 26 divided by 2. 26 divided by 2 is 13. And a negative divided by a positive is a negative. So we would have negative 13. So let me grab my calculator. And I'm going to use the calculator to demonstrate this problem that we had right here. So what they're talking about is if you're going to use a calculator to work out a fraction. So what we need to do is, and if I click that, it's going to go off. Never mind. I'm going to leave that alone. I'm trying to get rid of that toolbar that's at the bottom. But I've learned in the past, if you mess with it, it really gets screwy. So I want to put the numerator in parentheses, just like they've done here. So here's parentheses on my calculator, parentheses, and that is a negative 22. Also, note that on a calculator, the gray buttons that you see here, these 4 gray buttons, these are the operation buttons. But the negative sign is down here. So that is technically a negative 22. So do not use the subtraction sign to represent a negative number. They're two totally different things. If you do, the calculator is going to tell you you got an error, and it's not going to be able to calculate it for you. So that's a negative 22. Let's do minus 22. And I want to subtract from that the value of 2, and I'll put that in parentheses. So there's my numerator. Remember, every fraction is a division problem, so I'm going to put divide. Then I wanted to simplify the denominator, number at the bottom, so I'm going to use a parenthesis. Do 5 minus 3, close the parentheses. Now whenever I hit enter, it should give us negative 13. And it actually gives us negative 12. What did I do incorrect? Is the book incorrect? Negative 22 minus 2. Oh, I know what I did. I did not square it. Okay? So the book is correct. So let's try this again. Let's go ahead and do negative 22. And from that I want to subtract. It is 2 squared. So I need that button right there. There we go. This should fix it. Now let's do the divide by the quantity of 5 minus 3. And now, hopefully I get negative 13. And indeed, I do. So, again, in review, remember that all fractions are division problems, and the numerators have to be simplified, the denominators have to be simplified, regardless of whatever the other PEMDAS stuff is, because the numerator and the denominator is another way of grouping things. Just imagine that they have parentheses around them. They have to be simplified before the division can take place. And I think that's pretty much all I want to say about that. It sounds like Forrest Gump. All right, so on the next one, what about absolute value symbols? These are these parallel looking line things. So what we know about absolute value is that the absolute value of any number is equal to whatever that number is, only in its positive form. So we have a -5, it's going to be +5. If we have +5, then it's also going to be +5. It has to do with the distance from 0. That's what absolute value is all about, because -5 is 5 units away from 0, and +5 is 5 units away from 0. That's why the number for absolute value always comes out positive, because distance cannot be negative. So let's go ahead and work this problem out here. Absolute value symbols, they kind of work like parentheses. We have to simplify what's inside of the absolute value first. So let's rewrite right here. Now we have to deal with this 10 minus 5 squared. It's inside of the absolute value symbols. So 5 squared is 25. So now we need to do the 10 minus 25, which is -15. And like I said, any number that's inside of an absolute value, it just pops out and it becomes positive. If it's negative, it becomes positive. If it's positive, it stays positive. But it's the same value, only it's the positive form of that number. So absolute value of -15 is 15. Now all the time we've been bringing down this divided by 5. Now we can do 15 divided by 5 to get 3. Simplify each expression. So let's go ahead and do this 3a. I'm going to grab my calculator again. And we're going to use the calculator to do that problem there, since it is indeed a fraction. So let's go ahead and do that. So we're going to type it in just like we see in the problem here, only we're going to put parentheses around the numerator and also around the denominator. So open parentheses, we call these open parentheses, close parentheses, right? So kind of open, the first one opens it up, then we're going to close it off at the end with the other one. So open parentheses, 5 plus 2, and then we're going to do this parentheses, and that is a -8. And then I need a close parentheses. So see how we have 5 plus 2 times the quantity of -8, 5 plus 2 times quantity of -8, but we have parentheses around each of it. Now it's a fraction, so let's go ahead and hit the division operation symbol. And now do open parentheses again, and then just what we see here. Quantity of -2 cubed, so the quantity of -2, close the parenthesis. Let's raise that to the power of 3. Raise to the power of 3. I believe if I hit the over arrow to get out of that, there we go. And minus 3, and then close parenthesis. So you see that the denominator, quantity of -2 cubed, minus 3, quantity of -2 cubed, minus 3, close the parenthesis. Now I should be able to hit enter, and the answer here is 1. So let's go ahead and put that there. The answer is 1. We looked at absolute value on the example, so we'll go ahead and skip 3b. Let's look at 3c. This is a radical symbol here, and the value underneath the radical symbol is called the radicand. So we have to deal with the radical symbol first. So let's do a rewrite. 3 times the square root of 50 minus 1. So we need to simplify the radicand. That is the number underneath the radical symbol. So let's go ahead and 3 square root and 50 minus 1 is 49. Now I happen to know that the square root of 49 is 7, and this means 3. Notice there's no operation symbol. No operation symbol between the 3 and the square root radical symbol, right? So no sign, that means this is multiplication. So we need to throw a dot there for multiplying. Or another thing that we could do is, instead, we could just use parentheses. And the square root of 49 is 7, because 7 times 7 is 49. Now we can go ahead and do the multiplication. 3 times 7 is 21. You may need to use grouping symbols when translating from words to numerical or algebraic expressions. Remember that operations inside grouping symbols are performed first. So here we're going to be translating from words to math. And remember that look for words that imply mathematical operations, such as the word difference means to subtract. If we have the word sum or total, we know we need to add. If we have words like times or product, then we know we need to multiply. And if we have words like what's the quotient of, then we know that quotient means to divide. So translate each word phrase into a numerical or algebraic expression. First one says 1/2 times the difference of 5, -5, and 3. Difference means subtract. And they list the -5 first. So we need to have -5 minus 3. So the quantity of -5 minus 3. And we're going to use parentheses because we have to do that first. 1/2 times the difference of -5 and 3. So then we can put the 1/2, and again, no operation sign, so we know that means to multiply, so we're good to go there. Next is the square root of the quotient of -12 and n. Quotient means to divide, so we see a fraction here. Remember, every fraction is a division problem. So the quotient of -12 and n, since they said -12, it's the numerator, or they said -12 first, or they didn't say anything, the book didn't say anything. It lists -12 first, so that's the numerator. Quantity n is second, so that's the denominator. And then we want the square root of that. So we put the square root over the top, and we get the square root of the quotient of -12 and n. Example 5. Here we are with the sports application that we mentioned at the beginning of the lesson. So Hank Aaron's last season in the major leagues was 1976. At that time, I was 11 years old. A player's total number of bases can be found using the expression S plus 2D plus 3T plus 4H, and this means 2 times D, 3 times T, and 4 times H. Use the table to find Hank Aaron's total bases for 1976. S is for single, D is for a double, that's whenever you get to second base. T is for triple, that's whenever you get all the way around to third, and you hit it over the fence, or in some cases you might have an in the park home run, which is very uncommon. I saw it once on television, never seen it in person. I've been to a lot of baseball games as a kid. My dad used to take me, St. Louis Cardinals. So use the table to find Hank Aaron's total bases for 1976. So the first thing we need to do is substitute the values for each of the variables. So S single, D double, T triple, H home run. So how many singles did he have? We see 44. How many doubles did he have? There's 8. How many triples did he have? Well, 0, so we plug in 0 there. And how many home runs did he have? He had 10, so we'll plug in 10 there. Now, before we can do all this addition that we see here between these terms, we have to first multiply. So we bring down the 44. 2 times 8 is 16. 3 times 0 is 0. 4 times 10 is 40. Now add the 44 and 16 together, because now we can do all the addition since that's all we have left. 44 plus 16 is 60. Bring down the 0 and the 40. And now they're just going to add straight across. 60 plus 0 plus 40 is 100. So Hank Aaron's total number of bases for 1976 was 100. And finally, that brings us to our guided practice here. Vocabulary. Explain why the order of operations is necessary for simplifying numerical expressions. Well, if we didn't have an order of operations, then we wouldn't necessarily know how we're supposed to solve the problem. If somebody said, hey, we should do this first and then do that, or someone else said, no, we should do this first, then do that. If somebody said, let's do all the addition first, then we'll do the multiplication. And if someone else said, let's do the multiplication, then the addition, then you're going to come up with different answers. So it's necessary for there to be a set order of operations so that whenever we simplify numerical expressions, we all come to the same answer. On the next one, simplify each expression. Let's go ahead and we'll do number 2 first. So we have subtraction and division. So let's go ahead and divide the 12 divided by -2. Well, that's positive divided by negative, so that's going to be negative. So we're going to have, and actually I'm kind of holding up because I'm thinking, hey, let's go ahead and just put that in parentheses. And so let's bring our 5 minus. Then 12 divided by negative 2 is going to be a negative 6, right? Notice how I raised the negative sign up higher than the subtraction sign, so I don't get that confused. And 5 minus negative 6, here's a little trick of mine. I can keep the first number the same, change the sign, and then take the opposite of the number that follows the sign that I changed from subtraction to addition. This also works from addition to subtraction. We're going to take the opposite of the next number, and that's 6. That's going to give us 11. If you're uncertain about what I did there, about changing the sign and taking the opposite number, go back and check one of my earlier videos on the addition and subtraction of integers. Integers are non-decimal numbers that are positive or negative. Let's look at number 7. Number 7 looks like a good one. We have brackets, we have parentheses, we got some exponents going, so let's see how all this works out. Let's go ahead and bring our 16 down, plus, and we're going to get our bracket here, because the first thing we're going to do is this right here. So we have 5 minus the quantity of 3 plus, and I'm going to hold up here because I know that I have to work this little problem inside the parentheses first. So, what happened? There we go. So I have to deal with this 2 squared. Well, 2 squared is 4. So I'll put 4 there, and then the brackets. Now I need to continue to work from the inside out. So let's bring down the 16 plus the bracket, 5 minus, now 3 plus 4 is going to be 7. I still have my bracket. Now bring down my 16 plus, let's do 5 minus 7. Well, 5 minus 7, it's going to be a negative number because I'm subtracting more than I have. Some of you might be saying, negative 2, negative 2. Well, check this out. I can keep the 5, change the sign to addition, take the opposite of the number that I changed, that follows the, take the opposite of the value that follows the sign that I changed, if that makes any sense. So I changed it to subtraction to addition. The opposite of positive 7 is negative 7. So in this case, there are 2 different signs, so I'd actually subtract them. 7 minus 5 is 2. And the one with the greater absolute value, I'm going to use the same sign as that. 7 has a greater absolute value than 5. So I'm going to use the negative sign since 7 is negative. And so I would get negative 2. Now I'm going to do 16 plus negative 2. Oh, again, I have 2 numbers. One's positive, one's negative, so I'm actually going to subtract them. 16 minus 2 is 14. And 16 has a greater absolute value than negative 2. 16 is positive, so my answer is positive. So this answer here is 14. Looking at the next one, actually kind of cramped for space, and I'm looking at the time on this video. It's at 28 minutes. I think we're probably good to go on this. So I'm going to go ahead and leave it at that. And that is my complete presentation for Textbook, Chapter 1, Lesson 6, Order of Operations. Thank you.